Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 2 on copying angles and creating parallel lines. So Unit 4 is all about these things we call constructions. And in our last lesson, we learned how to copy a triangle, or better yet, we reviewed how to copy a triangle. All right, and in today's lesson, we're going to take that a little bit further and learn how to copy an angle and then how to use that to create parallel lines. So let's get right into it, shall we? Angles and parallel lines. Angles and parallel lines are very important ideas in geometry. In this lesson, we will see how to copy an angle and then use this construction to create a line parallel to a given line. All right, let's take a look at exercise number 1. In this exercise, we will learn the basic method of copying an angle. Let me get that protractor out of the way, sorry. There we go. Given angle A and point R shown below, we will construct an angle at R that is congruent to angle A. All right, letter A, draw a ray extending from R in any direction. Okay, so remember, I'm just trying to create an angle that is congruent to angle A. It doesn't have to be in the same orientation or anything like that. Now, it's probably pretty natural if you're going to draw a ray from R that you'll likely draw it more or less horizontal. So that's what I'm going to be doing right now. Okay, so I've got my ray and that's one of the two rays of the angle. All right, simple enough. Okay, let me move my protractor out of the way. Let's take a look at letter B. Draw an arc with a center at A that intersects both rays from A. Label the two intersection points B and C. Okay, so what I'm going to do, moving this out of the way, is I am going to put the pointy end of the compass down on A, and I'm going to extend it. Now, how far do I extend it? It really doesn't matter. I just need to extend it enough that I can draw a nice arc that intersects both rays of angle A. All right, just wanted to make sure. And it asks me to then label those points B and C. Okay, great. So I've got, this arc drawn, right? I haven't changed that at all. I'm going to just kind of move it over here for a moment. All right, let's take a look at letter C. Draw an arc centered at R with the same radius as that from B. Mark its intersection point with the ray starting at A. Label this point S. Okay, so I'm going to bring this over here without changing that arc length from before. I'm going to now draw a nice arc like that. I could draw a full circle if I wanted to. This particular problem then asks me to label that intersection point, point S. Okay, so far so good. Now, let's take a look at letter D. Draw an arc with a center at S. Draw an arc with a center at S that has a radius that is the length of segment BC. Be sure to measure and mark the arc on A first. Mark the intersection of this new arc with the one you drew in C. Label this point T. Okay, there was a lot going on there. All right, so let's just be clear about something. What I want to do is I want to use my compass and measure this distance, the distance from C to B. And I can either put the pointy end at B and mark it off at C, or the pointy end at C and mark it off at B. What I'm going to do is I'm going to put the pointy end here. First, I'm going to rotate my compass down a little bit. Put my pointy end here. I'm going to measure that length. Just make sure, yeah, that's pretty good. And now I'm going to draw that arc, okay? So I now have the length of segment BC measured on my compass. Now I know I don't have segment BC drawn, but you can kind of visualize it, right? Now what I'm going to do is I'm going to take my compass, I'm going to move it over here, put the pointy end down at S, and I'm going to draw exactly the same arc, and I'm going to label that intersection point. Whoops, I'm going to label that intersection point as point T. Okay, let's do one last little piece and we'll have it. Letter E. Draw a ray RT Using a protractor, verify that angle R or angle SRT is congruent to angle A or angle BAC. All right, so in other words, what I'm now going to do is I'm going to take my straight edge at R and draw a ray through point RT, or through T. And I have just copied that angle. Now, finally, why do we have our protractor here? Simply to verify that these two angles are the same measure. If I bring it up to A, what I see is that the measure of angle A is 50 degrees. If I bring it over here, I see that the measure of angle R is pretty darn close to 50 degrees. I seem to have had it at about 49 degrees. I actually consider that a success, if I can get it that close. They should be identical, even if they aren't. Now, by the way, I want to point something out. What I really did in this construction is I more or less copied a triangle, okay? What I don't have there are segment BC and segment TS, right? But if I drew them in, really what I had done is I had copied triangle ABC over to here to SRT, all right? And again, notice a common theme when we do copying something, right? I made a large arc over here, and then I copied that arc over here. Then I measured the arc from C up to B, or I measured that radius and made that arc. Then I came over here and put the sharp end down at S, which was equivalent to C, and I made exactly the same arc, thereby locating that intersection point in an equivalent spot to that intersection point. Now, let's talk a little bit about why this construction works. Exercise number 2. Explain why the construction above works. Be sure to cite one of the triangle congruence theorems in your explanation. Okay, so let's take a look at what we did. Now, I drew in segment BC and segment TS so that we had a triangle here and we had a triangle here. If I hadn't, it'd be hard to really cite a triangle congruence theorem. Now, right away, think about the first thing I did. I drew this arc in, which really made AB and AC the same length. Really, what I got down here was an isosceles triangle. Then I went up here and I literally reproduced this thing, which made this length, right, the same as that length. Now, I know that length is going to be the same, I get it, right? But then, by drawing in this arc and by drawing in this arc, right, I guaranteed that it ended up looking like that, all right? So I can say, by construction, remember that from our last lesson, by construction, AB is equal to AC is equal to RS is equal to RT, right? Also, by construction, we know that ST is equal to BC. Okay, so triangle RST is congruent to triangle ABC by side, side, side. Now, remember, I'm trying to justify why angle A and angle R must be congruent to each other. All I've done here, right, is I've justified why RST must be congruent to ABC. But of course, as soon as I know that that triangle is congruent to that triangle, then I know that angle R must be congruent to angle A by CPCTC. So really, when I copy an angle, what I'm really doing, right, even if you don't have these segments drawn in, BC and ST drawn in, is I'm really reproducing a triangle from here over here, which then allows me to say that that angle and that angle are congruent by CPCTC. All right? Let's get a little practice on this. All right, exercise number 3. Construct angle W such that it is congruent to angle Q shown below. Leave all construction marks. All right, well, let me walk you through this again, okay? The first thing I want to do is I just want to draw an initial ray, and it really doesn't matter how long it is because I'm not trying to reproduce a length here, right? So I'm just going to draw some ray like this, and I will right away just label that as W. Okay, great. Now remember, my first step in this construction is to bring my compass over, to put the pointy end down on the vertex of the angle I know, and draw some kind of an arc. Okay, then without changing the radius of that arc, I bring it over, put the pointy end at W, and try to sort of draw an arc that is a similar size. Okay? At this point, what I'm going to do is I'm going to bring my compass over and I'm going to measure the distance between the two intersection points along this arc. Oh, I'm close. Almost a little bit less. Come on. Well, that's about as good as I'm going to get with my electron. Ooh, that's right on the money. Right? I measure that distance. I bring the compass over here without changing this distance at all. And then I measure that. The X marks the spot. I move this out of my way. Bring this over. Rotate up. And I've got my angle. Right? And angle W now is congruent to angle Q. I just lost my pen. All right, let's get that. I think that might be the first time I've dropped my pen in quite some time. Maybe ever. Okay. That's lovely. All right. It's gonna be that kind of day. All right, but again, essential, right? I make an arc through the angle, right? I then reproduce that arc over here. I then measure the distance between that intersection and that intersection, between the intersections of the arc that I drew with the two rays of that angle. And then I reproduce that distance over here to find the equivalent intersection point here. Once I draw the ray through that angle and that angle will have the same measure. All right, let's move on. Now, the rest of this lesson we're going to spend on creating parallel lines. Now that we can copy an angle, or copy and angle, we can construct a line parallel to a given line that runs through a specific point, right? Now remember, we had this thing back in Unit 1 called the parallel line postulate, which said that if I had a line, let's say, and a point not on the line, there is one and only one angle that, one and only one line that will pass through this point that will be parallel to that line. So that's what we're trying to construct right now, is that particular line. So let's take a look at exercise number 4 and walk our way how to do that, through that. Now, by the way, every time I give you one of these where it's like letter A, letter B, letter C, letter D, what I'm trying to do is give you the recipe for how to do the construction, and then we'll eventually talk about why it works, okay? So exercise number 4. In this exercise, we will see how to construct a line parallel to line M that passes through point A. Letter A, draw a line that passes through A so that it intersects line M, mark the intersection as point B. Okay, here's probably the weirdest part of this construction. I need to draw a line that passes through A that intersects line M, and there are an infinite number of lines that'll do that. Okay, it doesn't have to be perpendicular to this line, although it could be. It could form an obtuse angle with this line or an acute angle with this line. It doesn't matter. We just have to have a line that goes through this point, all right, and intersects that line. That's all we need. We just need something like that. That's it. Okay? As long as it intersects, you're fine. Awesome. Letter B. Using the new ray drawn through point A as one of its sides, construct an angle at A that is congruent to the one that the new line makes with M. Okay, so understand this. Here I've got an angle, right? Now this is a little bit funky, but I want to try to reproduce this angle at point A where this line, this thing, right, is one of the two rays that I use. So all I'm doing is the construction we just did twice, but in a very specific context. I want to reproduce this angle right here. So let's remember how to reproduce an angle. All right, first thing I'm going to do is bring my compass over here, put the pointy end down at the vertex of that angle, widen it out, and make an arc. Okay, right? That's the first thing I'm going to do. Then I'm going to take my compass and I'm going to move it up to the vertex of my new angle, which is at A, and I'm going to make the same arc. Okay. Now, remember, what I'm going to do with my compass is I'm going to measure the distance between where this arc intercepts this ray and this ray. Okay. Now, I'm going to actually this time measure it from up here, although again, it really doesn't matter, but I'll explain why I'm measuring it from up there in a second. Oh, I want it to be better than that. Oh, well, that's as good as, maybe there. As good as I'm going to get. Okay, not bad. Okay, now I've measured that distance. So what is the equivalent of where this arc intercepts here? Well, it's where it's intercepting up there, right? So I'm now going to move this up to here, and I'm going to make the same arc, okay? So I'm doing exactly what I did in my last construction. I can now bring this over here, draw a line that goes through A and through that point, or that intersection of the two arcs, and now all I've done is reproduce the angle that was down here up here. That's all I did, right? I just did the same construction I just did. The weird thing about it is that the two angles, if you will, have one ray that they kind of share in common, right? That ray, well, at least this ray and this ray sort of overlap, if you will. Okay, well, believe it or not, you probably realize we've already constructed a parallel line, but let's just take a look real quick at letter C. Using a compass, measure both angles to verify they're congruent. So real fast, I'm just going to bring this up. Now, depending on how you drew your line, it could be very different. So for me, the original angle was 68 degrees, or thereabout, and my new angle is 68 degrees, or thereabout. Whoops, wow, that was cool. All right, so great, letter C, check, right? Now, letter D. Explain why the ray of the newly constructed angle that does not intersect line M must be itself parallel to line M. Extend this ray so that it's a line. In other words, right, up here, I constructed an angle. And we think about an angle typically as, okay, I have a vertex point and a ray, right? If I really want that parallel line business to go on, then what I'm going to do is I'm going to kind of extend this, right? So it's not just a ray, but so that it's a line, right? And now these two lines are definitely parallel, but let's talk about why that is in letter D. Explain why the newly constructed angle that does not intersect line M must be itself parallel to line M. Extend this ray so that it is a line. All right, so I know I read that before, but here's that construction all over again, except neater, right? Why am I now guaranteed that this line must be parallel to that line? Pause the video and see if you can remember something from Unit 3 on triangle proof why those two lines now must be parallel. Well, these two angles, right, are corresponding angles. And because corresponding angles are congruent, the lines that form those corresponding angles must be parallel. All right? So, the two angles that are congruent are corresponding. If corresponding angles are congruent, then the lines forming them are parallel, right? So we had a lesson in Unit 3 which talked about how to justify that two lines, or how to prove that two lines are parallel. And one of the two primary ways of doing so was to show that two corresponding angles were congruent. And if two corresponding angles were congruent, then those two lines, right, after being cut by that transversal, must be parallel. So that's the key, right? We simply force lines to be parallel by constructing corresponding angles that are congruent. It's really kind of cool. So let's take a look at a couple of those in practice. Exercise number 5. Construct lines parallel to the ones shown through the given points. All right, cool. Let me walk you through letter A and then have you do letter B on your own. So now remember, our first step, right? We've got to copy an angle. Our first step has to be to sort of create the angle that we're going to copy. I know that sounds a little bit weird, but it's true, all right? So I need to draw a line through point R that intersects this particular line somewhere, all right? So doesn't matter. You know, I could make it acute, obtuse, it doesn't matter. I just have to have it intersect that line somewhere. And then I'd really like this to rotate back up. Okay, great. So now I have an angle that I can copy. So let me copy that angle. I'm going to come down here to my angle that I know. I'm going to put the sharp end on the vertex of the angle, extend my compass to a certain amount, and draw an arc that passes through the two rays of that angle. I'm now going to bring the pointy end of my compass up to point R, and I am going to draw the equivalent arc. Okay, I got to make sure it goes through that ray. All right, I'm now going to bring my compass down and measure the distance between the two intersection points of the arc and the rays of that angle that I want to copy. Okay, I measure that distance. I bring that up. Kind of have enough room here. I bring that up so that the pointy end is on that intersection point. Draw the same arc. And now, as always, X marks the spot. I use that point and point R as the 2 points that will define the line that I want to draw. All right. I draw a line through R and that point, and I've got 2 parallel lines. All right, they might not be exactly parallel, but you get the picture, right? The idea is if I faithfully reproduce this angle up here, then this line must be parallel to this line because this angle corresponds to that angle. All right, let's have you do one on your own and then we'll walk through it again together. Why don't you try letter B on your own? All right, now for what it's worth, I tend to like to keep the angle that I'm trying to reproduce an acute angle. As we saw though, when we did that one with angle W where I managed to fling my pen onto the ground, you certainly can reproduce obtuse angles. It doesn't matter, all right? But I sort of like to keep them acute. So again, I first have to create an angle that I'm going to copy. That is probably the weirdest thing about this particular construction, is that, you know, you don't really have an angle to begin with. You have to make it yourself. So I make that angle myself, and then I get rid of my ruler for now. All right, so what I'm now going to do, as always, I'm going to come over. I am going to come in, draw an arc through that without changing the radius. I bring it over here. I draw a similar arc. I now come down here. I'm going to measure that distance from those 2 arcs. Oh, look at that. That's basically perfect. Right where it was. Come up here to this arc intersection. Draw the same thing. X marks the spot. There it is. Now I just need to use point B and that particular intersection point as my 2 points. And I now have my parallel line. And that's it. So it's a wonderful application, really, of copying an angle, right? So once you learn how to copy an angle, actually creating 2 parallel lines isn't so bad. All right, let's wrap this up. So today we saw two of the classic constructions that you are responsible for knowing whenever you take whatever big test you're going to take in geometry. One of those is copying an angle, relatively easy, and the other one is using copying an angle to create a parallel line that passes through a point that doesn't lie on a given line. Okay? Both of those constructions are going to be critical in what we do next when we look how to construct a translation. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.